Good morning, my dear students. In this video clip, I want to discuss about the energy of the electron in the orbit of an hydrogen atom. Energy. In previous video clip, already we discussed about what are the things. Bohr's postulates. 3 postulates, very important. And then you obtain the expression for the radius of the nth orbit of electron of the nth orbit of a hydrogen atom. Then you obtain the expression for the velocity, you obtain the expression for the time period, you obtain the expression for the frequency of the revolution of an electron in the orbit. Now what is the energy? Energy of the electron in the nth orbit of the hydrogen atom and for any atom. Yes. Now again, same thing you have to explain here. Now this is the atom. The central part is set to the nucleus. Charge is plus Ze, charge of the nucleus. Here Z is the proton number, E is the charge of the electron. Then R is the radius of the nth orbit of an electron, that is a stationary orbit. Then M is the mass of the electron, and E minus is the charge of the electron, and V is the velocity of the electron. Now, the nucleus is a positive charge. Definitely it produces the electric field. Around the nucleus there is the electric field. Around the charge, that is a charge, it means the nucleus, it is a charge. There is the electric field. There is the electric field. Definitely every point there is the electric potential. Charge ಇದೆ ಅಂದರೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಚಾರ್ಜ್ ಇದೆ ಅಂದರೆ ಅದರ ಸುತ್ತ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರುತ್ತೆ. ಅದರ ಸುತ್ತ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇದ್ರೆ ಆಟೋಮೆಟಿಕಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇರುತ್ತೆ. Now any charge is placed in electric field, okay, that is said to be an electron, definitely it possesses the electric potential energy. Hence that electron possesses the electric potential energy due to the electric field of the nucleus. This is one point. This is the potential energy. Next, another point. The charge is move around the nucleus in a particular orbit. Definitely it is moving around the nucleus, and definitely that is having the kinetic energy. It possesses the potential energy due to the electric field and electric potential, and it possesses the kinetic energy due to the motion of the electron. ಅದು ಮೂವ್ ಆಗ್ತದೆ ಅನ್ನೋ ಉದ್ದೇಶಕ್ಕೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕೊಡುತ್ತೆ. ಅದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ನಾಗ ಇರುತ್ತೆ, ಅದಕ್ಕೆ ಅಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ನೊಳಗೆ ಆ ಚಾರ್ಜ್ ಇರುತ್ತೆ ಅಂದುಬಿಟ್ಟು ಅದು ಏನು ಮಾಡ್ತದೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಕೊಡ್ತದೆ. ಡೆಫಿನೆಟ್ಲಿ ನಾವು ದ ಟೋಟಲ್ ಚಾರ್ಜ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಇಸ್ ಸಮ್ ಆಫ್ ದಿ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಆ್ಯಂಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ. Therefore total energy, potential energy plus kinetic energy, or kinetic energy plus potential energy. Now we come to the point. Again you come to the similar point, similar step. By Bohr and Rutherford, the centripetal force provided by, okay, the centripetal force of the electron revolving around the nucleus, it is provided by the electrostatic force of attraction, Fe. Now the centripetal force mv square by r, this is 1 upon 4 pi epsilon Ze into E divided by r square. Now it becomes Ze square. This is 4 pi epsilon naught r here, because here 1 r get cancel here, 1 r get cancel. Now you got the mv square. Now multiplied 1 by 2 on both sides. This is 1 by 2 mv square. Why? Because you obtain that expression in the form of kinetic energy. Due to this reason you have to write 1 by 2 mv square is equal to Ze square divided by 8 pi epsilon naught r. ಇಲ್ಲಿ 1 by 4 ಇತ್ತಲ್ಲ, it becomes 1 by 8. Now the kinetic energy is equal to Ze square. It is a positive Ze square upon 8 pi epsilon naught r. Fine, okay. Now potential energy. Potential energy at this point, at a distance r here. Now that potential energy is equal to electric potential at this point into charge of the electron. What is the electric potential at this point? This is 1 upon 4 pi epsilon charge divided by distance. Charge divided by distance. Ze divided by r into charge of the electron minus C. How that? Yes. Now U is equal to minus Ze square divided by 4 pi epsilon naught. Now this is the expression for the potential energy of the electron in the nth orbit of any atom. Okay, this is potential. Negative indicates it possesses the potential energy due to the force of attraction of the nucleus. ಅದು ಅಟ್ರಾಕ್ಟ್ ಮಾಡುತ್ತಲ್ಲ ಆ ಫೋರ್ಸ್ಗೆ ಈ ಏನು ಬರುತ್ತೆ ಎನರ್ಜಿ ಬರುತ್ತೆ. Now total energy of the electron is equal to sum of the kinetic energy and potential energy. Now kinetic energy Z square divided by 8 pi epsilon naught or minus Z square divided by 4 pi epsilon naught. Now you take the common Z square upon 4 pi epsilon naught or you take the common. Now remaining 1 by 2. But 4 into 2 8 agata. 1 by 2 minus 1. It becomes minus 1 by 2. Z square divided by 4 pi epsilon naught or minus 1 by 2. Now it becomes minus Z square divided by 8 pi epsilon naught, or it is the total energy of the electron in any atom. Substitute radius of the orbit of an electron in the nth orbit, epsilon naught n square s square divided by m pi Z square. Now substitute minus Z square divided by 8 pi epsilon naught. Wherever r is there, wherever there is r is there, you put this one. Epsilon naught n square s square divided by m pi Z square. Now you cross multiplication. You take this in denominator, you take here in the numerator m pi Z square. Here 8 pi epsilon naught into epsilon naught square n square s square. Now pi get cancelled here. What happens? M Z square e raised to 4 divided by 8 epsilon naught square n square h square. It is the expression for energy of the electron in the nth orbit of any atom. Any atom. For any atom. ಯಾವುದೇ atom ತೊಗೊಂಡ್ರೆ ಇದು expression. Now for hydrogen atom you have to write this is Z is equal to 1. Now you substitute Z equal to 1. It becomes minus m e raised to 4 divided by 8 epsilon naught square n square s square. It is the expression for the energy of the electron in the nth orbit of hydrogen atom. Equation number 6 for hydrogen atom. This is for any atom. This is for any atom. Now negative sign indicates it is due to the attractive force. The energy possessed by electron due to the force of attraction. Now n is gone increases. N square is also increases. Once n square is increases, now n value is decreases. ಅಂದ್ರೆ n ವ್ಯಾಲ್ಯೂ ಏನು ಮಾಡುತ್ತೆ ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ, ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ವಾಟ್ ಇಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ದಿಸ್ ಒನ್? Negative value of the energy of the electron decreases, it means actual value of energy of the electron is increases. Negative value ಕಡಿಮೆ ಆಗತಿ, ಅದರ ಅರ್ಥ actual value ಹೆಚ್ಚಾದಂಗೆ. ಅಂದ್ರೆ -30 ಜೌಲ್ಗೂ -20 ಜೌಲ್ಗೆ ಅರ್ಥ ಏನಪ್ಪ ಅಂದ್ರೆ -20 ಜೌಲ್ ಹೆಚ್ಚು. ಹೀಗೆ ಹೈಯರ್ ಆರ್ಬಿಟ್ ಹೋದಂಗೆ ಎನರ್ಜಿ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾಗುತ್ತೆ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ ಡಿಕ್ರೀಸ್ ಅದರ ಅರ್ಥ ಆಕ್ಚುಯಲ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎನರ್ಜಿ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾಗುತ್ತಾ ಹೋಗ್ತದೆ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ದಿಸ್ ಇಸ್ ಪಾಯಿಂಟ್. ಕೊನೆಗೆ ಲಾಸ್ಟಿಗೆ ಎನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎನ್ ಇನ್ಫಿನಿಟಿ ತಗೊಂಡ್ಬಿಟ್ರೆ ಏನಾಗತಿ ಎನ್ 0 ಆಗ್ತದೆ. ಈ ಎನ್ ಅದಕ್ಕೆ ಈ ಎನರ್ಜಿ ನೆಗೆಟಿವ್ ಅದರ ಅರ್ಥ ಎಲೆಕ್ಟ್ರಾನ್ ಈಸ್ ಬೌಂಡ್ ಟು ದ ನ್ಯೂಕ್ಲಿಯಸ್. ಈ ಎನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0 ಅದರ ಅರ್ಥ it is just escape from the orbit, and En positive is artha. Now the electron is free electron. Free electron ಯಾವುದು ಬಾಂಡ್ ಇಲ್ಲಪ್ಪ, ನ್ಯೂಕ್ಲಿಯಸ್ ಬಾಂಡ್ ಇಲ್ಲ, ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ, ಅದು ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎನರ್ಜಿ ಪಾಸಿಟಿವ್ ಇರುತ್ತೆ. ನೆಗೆಟಿವ್ ಅದರ ಅರ್ಥ ಇಟ್ ಇಸ್ ಬೌಂಡ್ ಟು ದ ನ್ಯೂಕ್ಲಿಯಸ್. 0 ಅದರ ಅರ್ಥ ಈ ಕಡೆ ಬೌಂಡ್ ಆಗಿಲ್ಲ, ಆ ಕಡೆ ಏನು ಫ್ರೀನೂ ಇಲ್ಲ, ಕ್ರಿಟಿಕಲ್ ಕಂಡೀಷನ್ ಇದೆ, ಕ್ರಿಟಿಕಲ್ ಪೊಸಿಷನ್ ಇದೆ ಅಂತ. This is very important expression for the energy of the electron in the nth orbit of the hydrogen atom. There are 3 expressions here. One is kinetic energy expression, another one is potential energy equation, and another one is total energy. Okay, thank you. Good morning, my dear students. In this video clip, I want to discuss about that is the frequency and wavelength and wave number of emitted spectral light. Yes. Now, this is the nucleus of charge plus 3. Then electrons are moved around the nucleus in the different orbits. These orbits are said to be stationary orbits. Stationary orbits are the now these are having the definite energy states. And they have definite energy. Suppose this is the first orbit, energy suppose you set to be E1, energy state second orbit E2, third one is set to be E3, like this. Here I want to take that is the two energy states. One is N1 state, energy state, and N2 states. Here En1 is the lower energy state in N1 orbit, and En2 is the higher energy state in N2 orbit. It is a higher orbit, it is a lower orbit energy state of the orbit. Fine, okay. Now, according to that is the Niels Bohr postulate, when an electron transition takes place from higher energy state to the lower energy state, then it emits the electromagnetic radiation. That electromagnetic radiation emitted energy is equal to difference in the two energy states. This is the Bohr frequency condition. Now, what you say that is the Bohr frequency condition? Whatever the emitted energy during the transition of electron from higher energy state to the lower energy state, it emits the radiation. That radiant energy is equal to difference in the higher energy state to the lower energy state. This is the Bohr frequency condition. Then, by the expression for the energy of the electron in nth orbit, En is equal to minus m e raised to 4 divided by 8 epsilon naught square n square h square. This is the energy of the electron in nth stationary orbit in hydrogen atom, because already you have to take here z is equal to 1. Here you have to take that is a spectral line, or that is H atom. It means hydrogen atom. Now we come to the point. Now when is the electron transition from higher energy state to the lower energy state, it emits the radiation, or you said to be radiant energy, that equal to difference in the two energy states. Now it gives the one spectral line. Here one transition, one spectral line. If number of transitions takes place, successive transition takes place, it gives the number of the spectral lines. This is for particular one spectral line. Now, energy of the in general is said to be energy of the electron in lower energy state. It means N1 state. This is N1 state. That is En1 is equal to minus m e raised to 4 divided by 8 epsilon naught square n1 h square. Now ಏನು ಮಾಡಿದೆ n square ಇರುವಲ್ಲಿ n1 square ತಗೊಂಡೆ. This is equation number 1 in hydrogen atom. Then energy of the electron in higher energy state, that is said to be N2 state. That is N2 state, that is En2 is equal to minus m into e raised to 4 divided by 8 epsilon naught square N2 square h square. This is the equation number 2. Now, energy emitted, or you said to be radiation. This is said to be radiation, emitted radiation, energy of the emitted radiation during transition of the electron from higher energy state to the lower energy state. This is by Bohr frequency condition. This is by Bohr frequency condition. E is equal to h nu is equal to En2 minus En1. Equation number, suppose you take, that is 3. Equation number 1 for lower energy state expression. This is the higher energy state expression. This is said to be difference in the two energy state. Now h nu is equal to you substitute this En1 and En2. That is En2 is minus m into e raised to 4 8 epsilon naught square n2 square h square minus n2 bracket minus m e raised to 4 8 epsilon naught square n1 square h square. Yes, it minus it becomes plus minus m e raised to 4 8 epsilon naught square n2 square h square plus m into e raised to 4 8 epsilon naught square n1 square h square. Here h is the Planck constant. Epsilon naught is the permittivity of the free space. M is the mass of the electron. E is the charge of the electron. C is the velocity of light. And lambda is the wavelength. Nu is the frequency. Here C is equal to nu lambda. Therefore, nu is equal to C by lambda. That I would substitute here. Nu instead of nu, C by lambda. Then hc by lambda, e term m e raised to 4, 8 epsilon naught square, n1 square s square minus m e raised to 4 divided by 8 epsilon naught square, n2 square s square. Now, hc divided by lambda, m into e raised to 4, 8 epsilon naught square s square is common here. Then what you got? 1 upon n1 square minus 1 by n2 square. Therefore, 1 by lambda I will take. M into e raised to 4 divided by 8 epsilon naught, C you multiply here, H you multiply, CH cube into bracket 1 upon n1 square minus 1 upon n2 square. Suppose you say this is the equation number 4. Now what is the wave number? Then when the waves, that is the number of waves are emitted, the number of waves are emitted in 1 meter, that is called wave number. Therefore, that wave number is nothing but reciprocal of the wavelength. Now, that is the wave number. Nu bar is equal to y by lambda. Nu bar is equal to m into e raised to 4, 8 epsilon naught square, ch cube into bracket 1 upon n1 square minus 1 upon n2 square. Equation number, how to take this is 5. It is also given by nu bar is equal to, it is the empirical formula by Bohr. By the Bohr empirical formula, mu bar is equal to r into bracket 1 upon n1 square minus 1 by n2 square. That usually that value is you have to write here. Mu bar is equal to 1.097. That is into 10 to the power of 7. 1 upon n1 square minus 1 upon n2 square. This is the empirical formula of the Bohr. Said to be Bohr empirical formula. Now this is the R is equal to, compare these two expression, that is the equation number 5 and equation number 6. Here that is R is equal to m into e raised to 4 divided by 8 epsilon naught square ch cube. This is called Rightward constant. It is the expression for the Rightward constant. Now you substitute all the values, mass of the electron, charge of the electron, and permittivity of the free space, and velocity of light, and the Planck constant. You got the answer is 1.097 to 10 to the power of 7 approximately. Therefore, this formula is agree with the empirical formula, Bohr empirical formula. Hence, this is said to be Rightward constant. Its value is 1.097 to 10 to the power of 7. It is the expression for the wave number. These two expressions, equation number 5 and 6. This is expression for Rightward constant. Okay. Now, from your equation, from this expression, this is hc by lambda, it means h nu. Now, as it is you have to write here, m into e raised to 4, 8 epsilon naught square h cube into bracket 1 upon n1 square minus 1 by n1 square. Now, nu is equal to, how to write, m into e raised to 4, 8 epsilon naught square h cube into bracket 1 upon n1 square minus 1 by n2 square. Equation number 7. It is the expression for the frequency of the emitted spectral line. Frequency of emitted spectral line. This is expression for the wave number. Then you have to write reciprocal of this one. You got the wavelength. That wavelength expression you got 1 by nu bar. Reciprocal of the wave number, you give the wavelength. These are the expression for the wave number, wavelength, and frequency of emitted radiation when electron transition takes place higher energy to the lower energy state. You have to take here in general. Okay, thank you.